4,000 meters beneath the surface of the ocean, there is no blue. There is no movement from waves. There is no sunlight trying to break through. The world above, with its storms, coastlines, ships, and continents, might as well not exist. At this depth, the pressure exceeds 400 times what you experience at sea level. If you were here, your lungs would collapse instantly. Air cavities in your body would compress. Even reinforced submarines must be engineered precisely to survive it. And yet something drifts here, not swimming, not hunting, just waiting. A faint blue light pulses in the darkness, small, almost delicate. But behind that light is a mouth lined with transparent spikes, and a biological system so extreme that it feels like evolution abandoned restraint. Nothing about the anglerfish is normal, and to understand why, we have to understand the place that made it. When most people imagine the ocean, they picture the surface, sunlight, waves, reefs filled with color. But that world represents a thin layer. More than 80% of the ocean's living space exists in permanent darkness. Below 200 meters, red light disappears. Below 500 meters, orange and yellow fade. By 1,000 meters, sunlight is gone entirely. Everything beneath that line exists in night that has lasted for millions of years. The anglerfish lives in this night, specifically in the Bathypelagic and Abyssal zones, regions so vast that they make continents seem small. This is the largest habitat on Earth, and it is the least explored. We have sent more missions to orbit the planet than to its deepest waters. Why? Because the deep sea resists intrusion. The pressure alone makes exploration expensive and dangerous. At 4,000 meters, the water pushes inward with thousands of pounds of force per square inch. Steel bends, glass shatters, electronics fail, but life adapted. Almost all ecosystems on Earth are powered by the sun. Plants convert sunlight into energy. Animals consume plants. Predators consume animals. Energy flows downward from light. But in the deep ocean, there is no sunlight. No plants grow here. No algae forests wave in the current. No coral gardens stretch toward brightness. Instead, the deep sea survives on leftovers. Fragments of dead plankton drift downward from the surface. Tiny organic particles fall like underwater ash. Scientists call it marine snow. It is slow, unpredictable, sometimes abundant, often scarce. Larger meals are rare events. A dead squid, a drifting fish carcass. Occasionally, a whale fall, when an entire whale's body sinks to the seafloor, feeding an ecosystem for years. But between these moments, there is nothing. And in a world defined by scarcity, biology becomes extreme. The anglerfish does not look fast. Its body is small compared to its head. Its muscles are soft. Its skin often appears loose and almost unfinished. But every feature serves a purpose. In environments where food is unpredictable, speed is expensive. Muscle requires calories to maintain. Active swimming burns energy constantly. So instead of evolving into a powerful pursuit predator like a tuna or shark, the anglerfish evolved into a patient one. It drifts more than it swims. Its fins make small, economical adjustments. Its metabolism is slow, dramatically slower than most surface fish. This is not laziness. It is survival. In the deep sea, wasting energy is fatal. Then there are the teeth, long, curved inward, nearly transparent. At first glance, they seem exaggerated, almost cartoonish, too large for its skull, too sharp for its body. But the anglerfish cannot afford to lose prey once it arrives. It does not get multiple attempts. When a potential meal drifts within range, the anglerfish opens its mouth with explosive speed. The rapid expansion creates suction. Water rushes inward. The prey comes with it. The teeth bend slightly to allow entry. But once inside, they prevent escape. They function like biological barbs. In shallow water ecosystems, predators often chase, bite, and tear. In the abyss, there is no room for struggle. It is capture or starvation. The anglerfish evolved certainty, but the anglerfish would not survive on teeth alone. Because in complete darkness, prey does not simply stumble into waiting jaws. So evolution added something extraordinary, a lure. Technically, it is a modified dorsal spine called the elysium. At its tip sits a bulb known as the esca. Inside the esca, live colonies of bioluminescent bacteria. These bacteria produce light through chemical reactions. The fish supplies nutrients and a controlled environment. In return, the bacteria glow. It is not bright like a flashlight. It is subtle, a soft blue-green shimmer. But in a world where there is no competing light, subtle is enough. Small fish and crustaceans detect the glow. They interpret it as food or as another organism. Curiosity pulls them closer. The anglerfish does not move much. It may twitch the lure gently, a slight motion, an irresistible signal in total darkness. And then, the strike. Bioluminescence is common in the deep sea. In fact, it is estimated that the majority of deep-sea organisms can produce light in some form, but they use it differently. Some flash light to startle predators. Some use it to communicate. Some use it for camouflage, matching the faint light from above to hide their silhouette. The anglerfish uses it for deception. It weaponized light. In an ecosystem where vision is limited and encounters are rare, controlling a signal gives you control over probability. The anglerfish does not chase opportunity. It manufactures it. But even the lure, even the teeth, even the energy-efficient body are not the strangest thing about this creature. Because what truly makes the anglerfish abnormal is not how it hunts, it's how it reproduces, and that is where evolution becomes almost unrecognizable. If the anglerfish only had glowing bait and oversized teeth, it would still be strange, but it would be understandable. A predator adapting to darkness. What makes it truly abnormal is something else entirely. In many deep-sea anglerfish species, the male is almost unrecognizable as the same animal. He is drastically smaller than the female, sometimes by a factor of 10. If you saw them side by side, you might assume they were different species. The female is equipped with a lure, massive jaws, and a body built for survival in the abyss. The male, he has none of that. No lure, no oversized teeth. In some species, he barely has a functional digestive system. He is born with one purpose: find a female, and if he fails, he dies. In the deep sea, finding a mate is not a simple task. Imagine drifting in an environment that covers more than half the surface of the planet. Pitch black, no landmarks, no light, no sound carrying clearly across vast distances. Two individuals could drift for years without ever encountering each other. In shallow ecosystems, animals rely on visual displays, territorial calls, or scent trails carried by predictable currents. But in the abyss, those systems break down. Distances are too vast, encounters are too rare, so male anglerfish evolved into seekers. They are born with enlarged olfactory organs, highly sensitive to chemical signals in the water. Females release pheromones, tiny molecular traces, and the male's entire nervous system is tuned to detect them. He drifts, searching. Every calorie he burns brings him closer to starvation. Because unlike the female, he is not built for long-term survival. He is built for urgency. When a male finally encounters a female, he does something that seems violent. He bites her, not to attack, not to feed, but to attach. His small jaws clamp onto her body, usually along her abdomen or flank. At first it looks parasitic, like a leech latching onto a host. But what happens next is far stranger. Over time, enzymes begin dissolving the tissue between them. Their skin fuses, their blood vessels connect. Capillaries from the male grow into the female's circulatory system. Eventually, they share the same bloodstream. This is not metaphorical. It is biological integration. The male becomes physiologically dependent. He no longer needs to feed. Nutrients flow to him directly from the female's body. And because he no longer needs to hunt, his digestive organs begin to degenerate. As fusion continues, the male's eyes shrink, his fins reduce, his internal organs atrophy, his brain function simplifies. He becomes little more than a reproductive appendage. In some species, multiple males attach to a single female. Each one fuses, each one becomes dependent. From a distance, they look like small growths along her body. They no longer resemble independent fish. They are living extensions, permanent, irreversible. This phenomenon is known as sexual parasitism, and it is one of the most extreme reproductive strategies in the animal kingdom. To understand why this evolved, you have to remove human bias. We value independence, autonomy, individual survival. Evolution does not. Evolution values gene propagation. If males frequently died before encountering females, the species would collapse. If rare encounters resulted in temporary mating and separation, the odds of successful fertilization would be low. So natural selection favored a more certain strategy. When contact happens, make it permanent. Fusion guarantees sperm availability whenever the female produces eggs. It eliminates the need for repeated mate searching. It increases reproductive success dramatically. From a genetic standpoint, it is efficient. From a human perspective, it feels disturbing. There is another detail that makes this even stranger. Normally, when foreign tissue attaches to an organism, the immune system rejects it. This is why organ transplants require immune suppression. But female anglerfish do not reject the attached male. Their immune systems evolved tolerance mechanisms. Some species lack certain adaptive immune responses entirely. This is extraordinary. They sacrifice part of their immune defense system to allow permanent fusion. In other words, they evolve to accept another organism as part of themselves. That level of biological compromise is rare, and it only makes sense in an environment where reproduction is nearly impossible by conventional means. But this strategy is not perfect. It is risky. If a male attaches to a weak or unhealthy female, his genetic future is tied to her survival. If environmental conditions shift dramatically, reduced immune complexity may increase vulnerability. Yet for millions of years, this system has persisted, because in the deep sea, rare certainty beats frequent failure. The abyss does not reward variety, it rewards effectiveness. In shallow oceans, reproductive strategies are different. Many fish release eggs and sperm into open water. Others guard nests. Some perform elaborate mating dances, but all rely on relatively frequent encounters. The anglerfish does not have that luxury. Its world is too large, too empty, too dark, so it evolved something that feels almost alien. A merging of bodies, a surrender of individuality, a biological contract signed in flesh. When you step back, the anglerfish becomes less grotesque and more mathematical. Every feature it possesses increases probability. The lure increases prey encounters. The suction strike increases capture success. The expandable stomach increases survival between meals. The fusion of mates increases reproductive certainty. Each adaptation addresses a single problem: scarcity, darkness, distance. It is not chaos. It is optimization under extreme constraint. But reproduction is only part of the story, because the anglerfish is not alone in its strangeness. The deeper scientists explore the abyss, the more they discover that the rules we assume govern life begin to break down. And to understand that, we have to go deeper still. At 4,000 meters below the surface, the ocean is not violent. It is constant. There are no crashing waves here, no hurricanes, no sunlight shifting with the seasons. Just pressure, uninterrupted pressure, more than 400 times greater than what we experience at sea level. And pressure does not simply squeeze the body. It attacks biology at the molecular level. Proteins, the microscopic machines that allow cells to function, rely on precise three-dimensional shapes. Under extreme compression, those shapes begin to distort. In most animals, that distortion would mean failure. Enzymes would stop working, cells would misfire, life would collapse quietly from the inside. But deep-sea anglerfish produce special stabilizing compounds known as piezolites. These molecules protect proteins from pressure-induced deformation. They act like microscopic braces, maintaining structure where it should not hold. Even their cell membranes contain higher concentrations of unsaturated fats, keeping them flexible instead of rigid under compression. Their entire physiology is chemically tuned for a world that crushes everything else. They do not resist pressure. They accommodate it. They accept it. They evolved around it. Most shallow water fish rely on swim bladders, gas-filled sacs that help control buoyancy. At abyssal depths, gas becomes a liability. It compresses violently, so anglerfish do not depend on internal air pockets. Their tissues are dense and gelatinous. Their skeletons are lighter and less calcified. Their muscles are reduced but efficient. Instead of fighting gravity and buoyancy through constant motion, they achieve near-neutral buoyancy through composition. They float with minimal effort, drifting, conserving, waiting. Even their metabolism reflects the abyss. Heart rates are slow, digestion is gradual, energy output is minimal unless absolutely necessary. In the deep sea, survival is not about speed. It is about sustainability. It is about making every calorie count, every movement matter. The anglerfish is not the only creature shaped by darkness. Down here, gigantism sometimes appears unexpectedly. Certain isopods grow to the size of small cats. Squid species develop elongated bodies and massive eyes. Other predators evolve oversized jaws and expandable stomachs. Scarcity creates an arms race not of speed, but of opportunity. If a meal appears once a month, you must be capable of consuming it fully. You cannot afford to be selective. You cannot afford to be wasteful. That is why some deep-sea fish can swallow prey larger than themselves. That is why some species evolve distensible stomachs and hinged skulls. The anglerfish's massive mouth is not an exaggeration. It is insurance. It is survival strategy made flesh. The deep ocean has existed for hundreds of millions of years, long before humans, long before mammals. Even during the age of giant marine reptiles, when mosasaurs and pliosaurs dominated surface waters, the abyss remained dark and cold. Surface ecosystems change dramatically across geological time. Continents shift, climates warm and freeze, sea levels rise and fall. But the deep sea is stable, cold, pressurized, dark, and stability, paradoxically, allows for the most extreme experimentation. That stability allows extreme specialization. While giants ruled above, the abyss refined subtle adaptations. Bioluminescence evolved independently dozens of times in ocean history. Ambush strategies became more efficient. Reproductive fusion emerged as a solution to isolation. The anglerfish is not a sudden anomaly. It is the result of millions of years of uninterrupted darkness shaping life without sunlight's constraints, without sunlight's rules, without sunlight's limitations. When people describe anglerfish as alien, they are not exaggerating emotionally. They are reacting to biological unfamiliarity. Humans evolved in environments filled with light, sound, and constant social interaction. We expect symmetry. We expect proportion. We expect visible faces and predictable anatomy. The anglerfish violates those expectations. Its mouth is too large, its teeth too exposed, its mating system too extreme, its glow too intentional. But it is not monstrous. It is optimized. The discomfort we feel is not fear of attack. It is confrontation with adaptation beyond our experience, beyond our frame of reference. The anglerfish reminds us that life does not follow human aesthetics. It follows physics, probability, scarcity, necessity. It follows the only rule that truly matters in nature. Survive long enough to pass on your genes. And in the abyss, that rule wrote a creature we can barely comprehend. Somewhere beneath miles of water, in a space where no natural light has existed for millions of years, a faint blue glow pulses softly. There is no sound, no warning, no chase, just patience. A small fish drifts closer, drawn by the illusion of food, by curiosity, by instinct. In less than a second, the glow disappears. The darkness returns. The anglerfish does not celebrate. It does not roar. It simply survives. Perfectly suited for a world that would kill us instantly. A world we can visit only briefly, and only with enormous effort. A world the anglerfish has inhabited for millions of years. Nothing about the anglerfish is normal, because nothing about its environment is normal. It is not a mistake of evolution. It is evolution pushed to its logical extreme. And the deeper we explore the ocean, the more we realize something unsettling. The surface is not the rule, it is the exception. The sunlit waters we think of as the ocean represent less than 5% of the marine environment. The rest exists in conditions we find hostile, alien, impossible. Beneath it lies a world older, darker, and far more patient than we ever imagined. A world that has been refining life in darkness since before there was life on land. A world that will continue long after we're gone.